Okay, so from here, I continue with this part lah. Okay, we still need to know the thermometer when they never calibrate. So that means they never give you a scale. Okay, they just want thermometer. After that, they never give you the scale. Then they want to find out the what's the temperature for one of the liquid. So what we need to do, so we need to calibrate the thermometer first. So we only can calibrate by 2 points. Because 2 points, we sure guarantee to know what is the temperature. So the first one sure is your water when you just boil. When you just boil, be sure that one is 100 degrees Celsius. So after that, another one should be you put your thermometer inside the ice. Inside the ice, you sure know there's a 0 degrees Celsius. So from here, we need to know the thermometer that does not have the scale and also can be carried by using the 2 fixed point. So when the question just asks you 2 fixed point for the thermometer, we only got 2. So this one is the first one, melting point of ice. This one is the first one, the fixed point. This is 0 degrees Celsius. Okay, another one, we call it as a boiling point of water. There's 100 degrees Celsius. So you can say one is a lower fixed point. Another one should be the upper fixed point. So this one is a 2 fixed point to help you to get what is the reading when you want to measure another liquid. Okay, so this one of the info you need to know. Okay, this word, when you see the word for thermometric property, okay, thermometric property, the meaning is what? That means a physical property that can be measured, okay, changes with the temperature. So I don't care what situation, if you're using alcohol thermometer. So they ask you thermometric property of this one thermometer is what? So that means something to let you to see. After you see, then you know what is the temperature. So we call thermometric property. Because sometimes the machine, they were never using the mercury, never using the alcohol. Maybe they're using the voltage. The voltage to find out what is the temperature of the machine. So that means when they show the thermometer, there's a voltage to show it. So they ask you what is the thermometric property for this one machine. So your answer is voltage. So because different object, we're using different temperature, or you say thermometer, to measure what is the temperature. So for the simple one, liquid, so we're using the mercury. Okay, sometimes we're using alcohol. So when they ask you thermometric property, in your mind, you must thinking what is represent the temperature. Okay, so for this one situation of mercury, the volume expansions of the mercury is represent the temperature. So this one is a meaning for thermometric properties. Okay, this one is one of the activity from your textbook. They just want to find out boiling point, what's the reading. After that, they want to find the melting point, what is the reading. So from here, this one is a procedure. Okay, so procedure, we're going to see the diagram. So they're using 2 situations. One is a beaker A. Okay, beaker A full with the ice. Okay, after that, they put the thermometer in. Okay, another one is using the heater. Okay, normally for the physics, we never using Bunsen burner one. Because Bunsen burner, the heat is not consistent. So we're using heater. Heater, normally the heat is consistent because we said how many watt already. So the heater put inside the water, so until boil. Okay, until boil. So you find out the thermometer, they will the mercury, they will heat up. When they heat up until 100, so we know that one is a boiling lah. So now we need to find out the light. Okay, using your ruler to measure when 0 degrees Celsius, what is the light? So that means when starting before you go to measure, they got a little bit reading here one. Okay, we just ignore. So until they start from 0, because they got negative, is it? We don't care about that. You just from the bottom go up until 0. I want to know this one is what is the light. So this one we call LO. Okay, so after that you go to measure. Measure until boiling. So this we call L100. Okay, So from here, we're going to check out when you want to put in another liquid. Okay, so now, wait, a bit wrong. This one not LO, this one not LO, because we never count by this one. We count this one, when they put in this part. Okay, when they're up, they show about 0, this one is a LO. Okay, so from here, we cannot say this one LO because they count from here. L100 from here, maybe LO this part. I don't know. So that means they count from the bottom until 100, maybe this small part is a LO lah. Okay, where your 100 start, where your 0 start, is the same point. Okay, this one is a thermometer. Okay, this one is your bulb. Okay, your 0 is here. So normally we count the 0. Okay, this one got mercury. Okay, your 100 we count from here one. Okay, 100, L100. So your L0, this part, that means exactly 0 lah, no reading. So L0 also is a 0 cm. L100, then we see how many cm. So we see another situation when the L0 got cm. So example, this one, like this. Okay, this one is a tube, like this. Okay, so like this one situation, or same like just I told you. Okay, example, this one is a 0. Okay, so this one I put inside the liquid, I don't know how many. Okay, here is 100. So this one I need to know how many lah. Where they want to count, they count from here one. They will show you from the bottom of the bulb until 0. There is how many cm. So this one we count it as a LO. Okay, LO. If I say the 0 is here. Okay, if I say the 0 is here, so that means I count this one is a L0. Okay, if a 0 is here, that means L0 is a 0 lah, no cm. Okay, this one L0 got something cm, I don't know how many. So the question will provide for you. Okay, so this one is a L100. Okay, your 0 is here until 100, so we say L100. Okay, so from here you can see one is a mistake, one student will make one. Okay, if I put 0 is here, okay, so I take this one. Okay, L100. I take this one is a L100. Okay, then I take this one is a L100 at the bottom here. What is the wrong thing? So if bottom is nothing, the question never show anything. Okay, they just share like this. Okay, 0 start from here. Okay, 100 is here. Okay, your L0 equal 0. So L100, I don't know how many, depends how many cm, maybe 80 cm. Okay, this one we call L100, then the L0 is a 0. Okay, if L0 bottom is here, they got show you this part. This one is a 2 cm. Then from the bottom until 100. So if you show you 2 cm, your starting point should be here. Okay, 2 cm, bottom, starting point up. If they never show you bottom, 0 already is a starting point, so we start from the 0 until 100. So it's just like this one diagram. They got show you 0 starting here. Okay, behind the 0, still got reading. Okay, L0. So your starting point must be here. This one is the starting point. So you cannot say, oh, how 100, I start from here until the end. No. Where your 0 start, you must start from the 100 also. Okay, cannot jump from the 100, from the 0 straight forward, go to 100. Okay, so we're going to try some explanation. So actually, they're using the ratio to do the calculation. So from here, I want to know data. So that means when I put inside one of the liquid, L data, I don't know how many. I also start from the starting point. All start from the starting point. Okay, when I just put, I find it, the length increase until this level. Okay, this level, I don't know what is the degree Celsius. I only know the length, how many. So I just want to using the formula L data minus L0. Okay, over L100 minus L0, then you multiply 100 degrees Celsius. Okay, So from here, this one is a formula. Okay, what's the label from the data? Data means the temperature of the liquid we need to know. L data means the length, okay, of the capillary tube of the liquid we go to measure. L0 means the length of the capillary when you put inside the ice point. L100 means the length when you put inside the boiling water. Okay, so this is one of the calculation we done before. So you can see the question they got mentioned for you. L100 is how many? L data is how many? Then the LO is how many? So the LO not exactly is a 0 cm lah. So this one 8.5, this one is 15.6. So that means your temperature for data sure is between 0 to 100 lah. If you do the calculation, you more than 100, that means you're wrong already. So from here, we go to show the calculation by using this formula. Okay, 8.5, because we take the L data minus 0, 8.5. L100 minus 0, 15.6. Then multiply 100 degrees Celsius. Okay, so we get our answer. The answer is a 54.5 degrees Celsius. So that means when I put in the L data, there's a 8.5 cm. What is the reading for the thermometer now? The thermometer is a 54.5 degrees Celsius. Okay, so this one calculation only can using when they just say the thermometer is not calibrated. Okay, if not calibrated, so you need to find out what is the temperature of the certain liquid. Okay, now we're going to see this part. This one is important when you just want to answer the question for AC. Okay, the AC question example, they show you, excuse me, some of the thermometer, different type, PQRS. So they ask you which one is the most suitable thermometer. So we need to know characteristic for the thermometer. Okay, the first one, the bulb, this one we call bulb, thin glass wall. So that means the wall of the bulb must thin. Why? Because we put in the liquid or you put in the ice. Thin wall means easy to absorb the heat, or you say easy to release the heat also can. So this one is one of the point they will ask you glass wall. You want thin or thick? The answer is thin. So how to answer? Give the reason. Heat transfer to mercury faster. So normally we say heat up, we never say cool down one. So when they just ask you, you want the thin or thick wall glass, so your answer is, I want the thin. And the reason, heat up faster. You can say heat up faster. You also can say the mercury in the bulb can heat up faster. Okay, some is increase sensitivity. Okay, this is one of the point to increase sensitivity when I'm using thin wall bulb. Okay, number 2. Okay, this is number 2. The bulb I want small. Okay, small bulb actually what's the function? Small bulb means the volume become less. When the volume become less means what? Easy to heat up because your quantity less already. So from here we can say to increase the rate of expansion of the mercury. Okay, you can see number 1 and also number 2, the explanation is almost the same lah, but I'm using another word to explain. So I say increase the rate of expansion of the mercury. So that means if your quantity become less, when I just heat it faster to heat up, easy to heat up. So from here, I don't want to mention easy to heat up. I'm using the word expansion rate increases. Okay, faster to expand. But this one we never mention sensitivity. No, only thin glass wall is increased sensitivity. Okay, the rest is no. Okay, now we go to second one, third one. Small scale. Okay, the scale is the smallest. Okay, but this one is normally related with this one. Number 3. Narrow capillary tube. So I can say the diameter of the capillary tube is very, very small. Okay, why I want to make it become thin? Because I want to make it small scale. When I make it thinner, they become taller lah. That means thinner, I don't want using the diameter is more. If your diameter thicker, that means you need more mercury to up I want it make it become narrow. When I narrow, that means I can detect the small changes of the readings. Okay, so when I just make sure there's a narrow capillary tube, that will increase the sensitivity and also increase in volume of mercury. Okay, increase the volume of mercury means what? You thinner already, the volume up faster. Okay, if your diameter thicker, so that means when the volume up, slow lah. When your diameter more ma, then just like the pipe. If the pipe is bigger diameter, water up slow because diameter is a big. I need more water to up. If I make the diameter become narrow, when the water up faster one, because narrow pipe. So this one also same. When the capillary tube become narrow, okay, first one you can say increase sensitivity. So increase sensitivity only got two. One is a thin wall bulb, another one is a narrow capillary tube. But don't cross. When you write the essay for the explanation, don't cross the explanation. Okay, when just say thin wall bulb, you say, or increase sensitivity. Then narrow, you also increase sensitivity. Maybe you cannot get the full marks. So we do using the same explanation. If you mention narrow, then you're using increased sensitivity. Another one just using another word to explain. Okay, so from here, narrow capillary tube increase the sensitivity. Why they can increase? Okay, the reason is here, small scale. So when you become narrow already, that means become longer. Longer, I can make the scale become more detailed. Okay, maybe the normal can read 40 degrees Celsius, but this one can read 40.5 degrees Celsius. That one is small scale. So small scale, another reason you can explain this one, can detect the small changes of temperature. Okay, this one is another point you can answer for narrow capillary tube. Okay, and the last one is the number 4. Okay, glass tube. Okay, they will ask you about the transparent opaque. Okay, opaque means transparent. That means the light, when it just come in, they never reflected. That means the light can go through the liquid. So there's a one of the transparent. Okay, number 2, the level of the liquid can be seen easily. So they never stick to the glass. So they never stick to the glass. So that means when you read the reading, very clear. This one reading is how many. And also there's a transparent. So they never let you to see got image. Okay, the refraction got image. No. Straightforward, opaque. After that, the level of the liquid can be seen very clear. Okay, another one strong. Okay, the stem. When you just see from here, you can see the stem like this. Okay, normally it's a round. We never see the thermometer got square one. Normally it's a round. After that center, you can see one dot like this. This one is a mercury. Okay, so from here, the question normally we ask you about the shape. Okay, the shape, we need curve. Okay, the curve shape. Number 2, the stem is a thick. Okay, so from here, this one is a reason. Strong and not break easily is a reason for the thick. Okay, you can see the glass and join with the mercury. The wall inside is a thick. Bulb is thin. When you're up ready, inside the glass, that one must be thick. Okay, reason is strong and not easy to break. Okay, and the last one is a curve. Why there's a curve shape, they're not square shape? Curve shape act as a magnifying glass. Okay, the curve shape, they act like the magnifying glass. You also can say reduce the refraction. If you got rectangle or square, you got this one. The corner and corner, when the light just go, they will refract it. So we choose this a round one. The round one can make it magnify the reading. They also can reduce the refractions. Okay, this one is the question they can ask you about the thermometer characteristic. Okay, but normally they will ask about thin wall bulb. Okay, thin wall bulb. And number 2 is a narrow capillary tube. Then the next one, maybe they ask you about the the color. Okay, the color, how? The color you want easy to see or not easy to see, or they ask you about opaque. Okay, you want opaque or you don't want opaque. And the next one, maybe they ask you about the stem. The stem you want thick or round, and also round. Thick and also curve like this. So you need to give the reason. Thick, sure is a strong. Number 2, curve, sure is a magnifying glass. Okay, so this was one of the question. Later we got, you can refer your paper behind, they got 2 essay. Okay, the essay almost like this. Okay, now you see this one, example 1. I think not inside your paper, is it? Go and check. Got example 1. So from here, we can see this one. The length of the mercury coulomb, ice point. The question already give you ice point. So ice point is how many? 5 cm. Okay, this one is a steam point. Steam point is a 40 cm. So I label lah. LO 5 cm, L100 40 cm. Then after that, they say immerse inside the liquid P. Okay, the line become 23. So I label this one L data, 23. After that, they ask you what is the temperature of this one liquid P in SI unit. SI unit is what? Kelvin, not degrees Celsius. So that means you find degrees Celsius first. Later we go to convert. So we show the formula first. I show you formula. L data minus L0, L100 minus L0. So I put in 23 minus 5, 40 minus 5, multiply 100. So I get 51.43. Okay, now I want to get SI unit. Okay, how many here can tell me? 0 degrees Celsius got how many Kelvin? Okay, Chen Yu, you know or not? I think your from 1 until from 3 got learn, is it? Chen Yu, how many?
I don't know.
You do know? Okay, how many here know? Just type for me. Jia Yi, you know or not?
324.43.
No, you answer me this one first. 0 degrees Celsius, how many Kelvin?
27,
27.
273.
Okay, yeah. 0 degrees Celsius is a 273 Kelvin. Okay, so that means now I got, if I say 1 degree Celsius lah, okay, you are 274 lor. Okay, so from here now I'm 51.43. So you just plus 273. Okay, so your answer is 324.43 Kelvin. Okay, so this one is your answer. Okay, so one more thing to tell you, these 2 years, for the SPM result, SPM, the calculation question, they catch very strict. They want you write 4 significant figure. So example like this, 324.43 already 5, is it? Okay, some student they write, maybe they want to change, become standard form. Okay, 3.24 times 10 power of 2 Kelvin. Like this means what? You only got 3 significant figure. They will minus your mark. Now they catch very strict because many students make easy to score, so they want to catch the decimal point. So better if you write standard form, you also need to write 4 significant figure. Okay, like this. Like this. Okay, especially your chapter 3. Chapter 3 got so many calculation and also the reading is quite big one. Better you write 4 significant figure. Okay, if you really don't have 4 significant figure, only 1.2, no more already, behind is nothing. So you just 1.2 lah. Okay, this one is a no choice really. Okay, don't tell me 1.2, you write 0, 0, 0 behind. No need. Just 1.2, that's all. Okay, so this one is one of the point to tell you all. This one is a new marking scheme for the SPM. Okay, they want to catch the student, just write 1 digit or 1 decimal point only. Okay, so better we set 4 significant figure. Okay, then this one is the answer. 324.43. Okay, Kelvin. Okay, then we go to second. I think this one also don't have until example 3, but let's start your example 1. Okay, distance between 0 to 100 is 25. Sometimes they're using this word. 0 to 100 is 25 cm. What's the meaning? L100 is 25 lor. This one meaning like this. When the thermometer is put into the beaker of the water, okay, mercury, then becomes 16. So this one is a L data. Okay, then the question never mentions 0. Because from the 0 go 100 already 25. So L0 how many? L0 is a 0. Okay, they will mention means they straightforward tell you the length is how many. So that means when 0 degrees Celsius, what's the length? It's a 0. Okay, now, so from here they ask you what is the temperature of the water? Okay, water put into the water, the length of the mercury up 16. So I know 16. I need to using the calculation by using the formula. It's the same. So 16 is a L data minus L0. So this was a L100 minus the L0. So multiply 100 degrees Celsius. Okay, the question never say SI unit. So I can straightforward take 64 degrees Celsius. Okay, this one for the A. Okay, for the B, what is the length? Okay, terbalik. What is the length? They want to find L data. Okay, is how many? When they say data is a 30 degrees Celsius. Okay, the formula is the same. Just we need to move the formula only. Okay, so 30 I just put here. L data I don't know, minus 0. 25 minus 0, multiply 100. So I find the L data now 7.5. So that means you need to know your reading for L data must between 25. Cannot over 25. 25 already is a maximum. So now they say put inside the liquid is a 30 degrees Celsius. So your reading here is almost 25, halfway lah. No, we don't know how many, maybe more or less, but cannot more than 25. That's all. Okay, 1 and 2, just a simple calculation. Okay, now number 3. Okay, number 3 is your question. So number 3, you can refer your question already lah. We do together. Okay, the question they got, please must write the info. Info is very important. Okay, so the thermometer at the 0, 2.6. So I label L0, 2.6. And 22.6 is 100. So put inside the mercury, that becomes 16.9. So I need to find what is the temperature. So apply the same formula. Okay, 16.9 minus 2.6, 22.6 minus 2.6, multiply 100 degrees Celsius. Okay, so the answer is 71.5 degrees Celsius. So this one question is quite simple. So I will ask, will teaching become fast lah. Okay. So we go to number 4. Your question is a number 2 lah. Okay, given that the alcohol glass thermometer not be calibrated, the length of the alcohol when it's inserted inside the melting ice, okay, and also the boiling water. Okay, one is a 3.5. 3.5 means sure is the L. 0 lah, 3.5. Okay, this part. Okay, when I just put in the steam one, boiling point, boiling water, this one is a L, 100. Okay, after that, they put inside the one of the liquid, don't know what's the liquid, they find this one. Okay, so we just do the calculation by using the same formula. Okay, so L data, you just put in 7.8 minus 3.5 over 13.7 minus 3.5, multiply 100 degrees Celsius. So I get the answer is 42.16 degrees Celsius. Okay, so this one question, some students say, okay, can I write 42.2? If 42.2 you do calculation, that means you only 3 significant figure. So better you write 4 significant figure, 42.16. If you do your calculation, I got so many, the number is behind. You round the number must correct. Round the number correct, don't 164. Then you just write 17, then you wrong already. Okay, because the 4 cannot round the number. round number must correct, and also 4 significant figure. This one is a SPM, what they need. Okay, then the following is the question number 3. I think this one you do already for the last lesson. I already show you the answer. Okay, I show again for the student you absent for last week. Okay, this one is the same calculation. L0 is a 0 because they start from here. They show you the ice point is straightforward. Start from the ice point, go to the steam point. So remember, they show you 20 and show you 15. So L100, you need to plus yourself, 20 plus 15. Okay, so this one's a L100. So the final answer is 42.86 degrees Celsius. Okay, then now we go to example 6. I think this one is your question for number 4. Okay. Okay, the length of the mercury is an uncalibrated, same. Okay. So what would be the temperature when the mercury put inside? There's a here. So we just write the info. Okay, 3. After that, the increase until 28. So this one 28, including the 3. Start from the 0, go up until 100. So the increases until to 28. So we take it 28 cm. Then after that, 23. Then the data. Okay. So we just put in all the things, just put in 23 minus 3, 28 minus 300. So I get 80 degrees Celsius. Okay, so this is one of the questions normally they ask for the 4 marks question. Oh, wait, for the 4 marks question. Okay, this is 4 mark question. They come out from the essay lah. Because essay we got one is a 10 marks for the PQRS. You go to choose. Some in front they got definition, they got comparison. Then they got process. This one called process question. So they just show you a diagram. They show the thermometer in the clinic that used by the doctor to check the temperature of the patient body. Explain how the doctor can check the patient temperature. So they call it to explain. So explain by using principle. What principle we use? Okay, the principle concept we use is a thermal equilibrium. This one you must mention when you go to explain. Okay, so the first one you must mention where you put the thermometer. Okay, so from here the first one, thermometer must be put, or you say under the tongue, or you say put inside your mouth, put below the armpit, also can. Okay, important you put in the part that's easy to absorb the heat. So you put under the tongue. Okay, so this one's the first point. Second point, you must mention the heat start to transfer. Okay, transfer from where? Normally from the hot. Okay, hot is a bigger size, then must transfer to the cool object. So from here must from the patient body, okay, to the thermometer. So this one we call heat transfer. So you need to mention the word heat transfer, where to where. Okay, where to where. Okay, number 3 must say after. Don't be so fast. After some time. Okay, you'll say after a while. Okay, now we can find it. The net flow of the heat 0. Okay, this one must mention. Net heat flow, or you say net flow of heat is a 0. Okay, then the last one. Now the thermometer reading, that means the temperature of the thermometer, same as the patient body temperature. And then we baru can finish the 4 marks question. How to measure the patient temperature. Okay, so this one, remember the first one where you put, because you want thermal contact. So you must say where you put. Number 2, after put, what happened? The heat start to transfer from the patient to the thermometer. And number 3 must say after some time. Okay, you find it. Okay, you can say the thermometer first. You find it, the patient temperature, same as the thermometer readings. Then the last one, you baru say net flow of the heat is 0. Okay, this one is the how to answer. This one either 4, this one either 3, also can. So these 2 points can help you to get the mark because these 2 points is for the thermal equilibrium, the main point. Okay, these 2 is a main point. Okay, so from here you can see the question, this one. Okay, I think that's your example 5. Your example 5, huh? Okay, so from here they show about the mercury thermometer has not been calibrated. Okay, after that they want to measure the temperature of the hot oil. Okay, state the physical change in the mercury when the temperature increases. You tell me what change. Okay, when you put inside the hot oil, wow, they keep increasing. Actually, what changes? Okay, Chen Yu, actually what changes?
The liquid movement.
Yeah, the liquid movement. How you see the liquid, the area or volume?
The volume.
The volume of what? Mercury, yes or no? If the mercury
Yes.
never move, we do know what is it. So important, the volume of the liquid inside the thermometer. That one is represent the temperature. So from here, they ask you physical change. They never ask you what liquid, because liquid already mentioned there's a mercury. So the physical change is a volume. Okay, it's volume. Okay, volume represent the changes of the mercury. Then you know what is the temperature now. Okay, why is mercury used in thermometer? So now we need to know advantages for the mercury. So first one, high boiling point. Okay, high boiling point, the meaning is when I heat until 100, mercury still is a liquid, never become gas. So this one we call high boiling point. Not easy to changes become the steam. Okay, so this one high boiling point. Okay, opaque means the light can go through the liquid. Okay, they never block. Example, if you put the some of the liquid example using the petrol, when the light just cannot see already. They cannot go through. Okay, some the liquid cannot go through. You put the coffee, light go, cannot see already. But the mercury can see. There's a transparent. Okay, when the light just pass through, you also can see. Okay, what is the reading of the temperature? Okay, do not stick to the glass wall. And this one important. When they expand, they totally expand one. They never bring a little bit expand, then little bit stay here. No. If like this, I also do know how to read the reading. They straightforward, the whole thing drop. Then the upper part, nothing ready. So this one is a point why we choose the mercury. And the last one is a good conductor lah. Okay, when they just absorb the heat, they go to expand. There's a good conductor. So this one, either one is one of the reason why we choose the mercury in as a liquid in the thermometer. Okay, now the working of the principle of the mercury thermometer. Okay, what is the working principle? So we're using what principle to explain the thermometer? Okay, anybody know? Okay, we go to ask Brenda. Brenda, do you know what the principle we're using for the thermometer? Okay, the thermometer, remember the principle from the heat. The first topic we learn about the principle. Okay, the principle is for the thermometer example, you think lah, how I know the temperature of the thermometer? Sure, the mercury need to expand. No? How to make the mercury go to expand? Two objects must be contact. No? If no contact, how to expand the mercury, is it? Okay, when they just contact already, then the heat must be transferred. Okay, until certain level, then they will stop. Then I go to read the readings. So this one is what principle? Okay, so we ask Hongzhen, this one is what principle? Principle for the chapter 4.1. The name.
Thermal equilibrium.
Yes, thermal equilibrium. Principle, not the name exactly, must have the word principle. So that means they're using what concept, actually what concept for the working of the thermometer. So the answer is thermal equilibrium. So they're using this one principle. Finally, you can read the reading from the thermometer. Okay, So this is the answer for the 7. So we continue for number 3. Okay, number 3, they say give one suggestion how to increase sensitivity. I told you already, we got 2 points can answer sensitivity. One is what? Thin wall bulb. Okay, the bulb at the bottom, the wall must be thin. Number 2, narrow capillary tube. That one is the point for increased sensitivity. So they say one suggestion only. So we just write one. Okay, smaller bulb. Okay, smaller bulb suppose not the main point lah. So important is a thin glass wall and smaller capillary tube. Smaller, or you say narrow capillary tube. Okay, these 2 is the main point for sensitivity. Okay, the rest we got another explanation. So only these 2 main is a sensitivity lah. Okay, another word to explain the sensitivity is able to detect the small changes. This one also another word. If you're using sensitivity already, another thing also sensitivity, but we cannot crash what? Cannot using the same explanation. So you can using this one, able to detect the small changes. This one also is one of the explanation represent sensitivity. Okay, able to detect the small changes. Changes of what? Changes of reading. Okay, changes of readings. Okay, now C calculation. The length of the mercury in the thermometer 1.6 cm at 0. Okay, L0 1.6. Okay, put inside the steam point 21.6. So they ask you what is the different length. Okay, Coulomb 0 to 100. They never ask the data first. They ask you what's the different length. So different length, simple we just take the biggest minus the smallest, there's a different length. Okay, 21.6 minus 1.6. So the difference is a 20 cm. Okay, so when the thermometer is placed inside the hot oil, okay, I find it the mercury go until 18.9. Okay, calculate the temperature of the hot oil. Okay, so the info here, okay, 18.9 still cannot achieve 21.6. Okay, it's still less than 100 degrees Celsius. So I go to find out, okay, using the formula. So L data is 18.9 minus 1.6. Okay, 18.9 minus 1.6. L 100, 21.6 minus 1.6. Multiply 100 degrees Celsius. Okay, so the final I get it 86.5 degrees Celsius. Okay, you check is it got decimal point or not? If got decimal point, you need to write the full. Because I'm from here I forget to write the full one. 21.6 minus 1.6. Okay, so suppose is no, nothing only. 86.5 only. Behind is nothing. So like this, okay. Okay, no need for significant figure because until 86.5 finish already. Okay, so this one also can because we no choice. We don't need to put 1 0 behind, only one. Okay, so we go through the next. There's an example question. Okay, example 8. Okay, from your notes is a 6. Okay, which following characteristic is used in the function of liquid in glass thermometer? Okay, we using what characteristic? Okay, so from here I want to ask the answer from Wen Xuan not here, Jia Yu. Okay, see who is here. Okay, Enqi, give me the answer for this one, number 8. Which one following characteristic used in the function for liquid in the glass thermometer? Okay, we use it to measure what?
boiling point of the liquid.
Yeah, boiling point. Okay, you don't go to answer volume of the fixed mass of liquid. We don't want to find the volume. Actually, we volume just represent. Okay, important we want to find is a melting point, boiling point, something like this. Okay, so B is the answer. Okay, then we go number 9. Which of the following method can be used to increase the sensitivity? Sensitivity again. Okay, so we go to ask the answer from Xiaoling. Xiaoling, what's the answer for sensitivity of the mercury? Which one can increase? Okay, answer boy. Yeah, correct. There's a thinner capillary tube. Another one is a thin wall bulb. Okay, this one is a 2 of the sensitivity. Okay, then we go example 10. That one is your example 8. Okay, your example 8. An alcohol in a glass thermometer has not been calibrated again. When insert into the melting ice, boiling, okay, 5.2, 13.7, then put inside another cup of the water. I find it 9.8. So calculation is the same. Okay, just repeat only. Then the last one, okay, 54.11 degrees Celsius. Okay, there's no problem. Okay, then the following.